Here we go. 5.6, justification and proof. Will somebody read that first paragraph for me, please?
Sure.
Thanks,
Hold on.
Hadassah.
I gotta turn the page.
Hold on.
Hadassah, gotta redraw the one thing. Oh, yeah.
Okay. The diagram from How Do You Know That has been extended by repeatedly rotating the image triangles around the midpoints of their sides to form a tessellation of the plane, as shown below. Using this diagram, you have made some conjectures about lines, angles, and triangles. In this task, you will write proofs to convince yourself and others that these conjectures are always true.
Yeah. All right. We are also going to put our homework away, please. Thank you.
Evens.
Yay. Okay, the first thing, vertical angles. Here's what we got. When two lines intersect, the opposite angles formed at the point of intersection are called vertical angles, as we have discussed. So I have highlighted here two vertical angles, BEA and CED. In the diagram, angle AEB and angle CED form a pair of vertical angles. So I have them listed there, or shown there. What we have given to us is that we have line AC and BD intersect at E. What we need to prove is angle AEB is congruent to angle CED. Okay. We're going to do a two-column proof. So, all we have given is that we have some lines that cross at point E. And we need to prove that BEA is congruent to CED. So let's talk through this first. What are some things about lines that might help us say that?
They have a constant slope.
They do have a constant slope. What other things about lines might help us say this? What are other facts you know about lines?
A line will only words. If you have two lines, they will only ever intersect at a single point.
That's true. Other things?
I don't know, the angles of the intersection of lines all have to add up to 360? Is that?
Yeah, that's a great one. Because we want to start dealing with things that are a little bit more algebraic here too. So they add up, all four angles would have to add up to 360. Jacob?
Or 180 degree.
Oh yeah, a single line is 180 degrees, right? What is it called when we have two angles that make up a straight line?
Supplementary.
They are supplementary, but there's an even more specific name for it.
Linear angles.
They are a linear pair. Okay? So we know about linear pairs that they add up to 180. Do you see any linear pairs here?
Yes.
What do you see?
BEA and AED are linear pairs.
I see this right here. Very good.
CED and DEA are also linear.
Ooh, and this right here. Now check that out. Now we have a way to relate our two vertical angles. What you working on there, Hadassah? Are you drawing or focused?
I am focused.
Okay, I would like for you to answer my questions too, please. Thank you.
They've just been stealing the stuff.
That's true. They're very good at. Yep. Okay. So we have a couple of sets of linear pairs. So what is common between these two sets of linear pairs right here? What's the common angle between them?
It is AED.
This one right here. So if I were to say that we have those linear pairs, and then I were to say I'm going to take out angle AED, what would be left?
Whatever 180 minus AED is.
True, how could we refer to that as an angle in this image?
The linear pair to AED?
Yeah, which is what? What's one of them? Because we found two, didn't we?
BEA.
Yeah, so that's this one right here. And what's the other one?
CED.
CED, right here. So if we can say these are linear pairs, they add up to 180. Then we can say, okay, if they both add up to 180, then we could set them equal to each other, right? Because if two things are equal to 180, those two things have to be equal to each other. right? Then we can get after that saying, okay, well, what if I take out angle AED from both of those? All you'll be left with is whoop and whoop.
What about
I'll be
BEC?
right back.
Okay, bye. So we didn't talk about BEC at all because we didn't use it in any of our linear pairs. So we don't really need to worry about it. It's unnecessary.
Jacob, move and say, I see a face.
I know, I was thinking the same thing. So it has a beard this time. Beard and
Why does it have
spectacles.
one eye, 3 sets of ears?
Yeah, it's kind of weird. All right, so let's go ahead and get started writing this proof, okay? So here's what we're going to do, and I'm going to also, let's see, take a screenshot of this, and we are going to work in my notes app.
Weird.
Just send that randomly to Miss Stoltz.
That would be awkward.
That would be really funny. Look at this smiley face.
Just airdrop it to her.
Can you see the face?
Look what we did
This
in
is my
math.
sleep paralysis demon.
That's awful, Tayson. Okay, so here we go. So in a 2-column proof, we have, how many columns do you think?
2.
Very good. One of them is for statements. The other is for reasons. Now, as we do proofs, we need to know something. We always must start with the given. So when we make our first reason, it will always be given. So what was the given for this proof?
Segment AC and BD intersect at E.
Was it segments?
Or lines.
Yeah, it was lines. Very good. So line BD intersects line AC at point E. Very nice.
Is there a fancy algebra for point, or is there just you have to write point?
I think you just have to write point. That's a great question. Actually, I think we could eliminate it. I think you could just say at E.
That's what I said before.
That's
Okay.
what I said. I said at E.
Oh.
And then I fixed it to point because I was like, oh yeah, it says point.
Schloop. At
Well, no, because
E.
above it says just intersects.
Okay, what's the next thing that we said? Yeah.
Above it says intersects at E. It doesn't say at.
Oh, nice. Sweet.
BEA and AED are linear pairs.
Very nice. I like that. So BEA, angle BEA, and angle AED are a linear pair. How can I say that? What's my reason?
Definition of a line? I don't know.
Kind of. It's actually going to be a little bit more specific. It's a definition of a linear pair. But you were right on track with that.
How many statements are there? Like, how many are there gonna be?
Like
We'll
seven.
find out.
There are probably going to be about 7, yeah.
Let's go.
I have like no space.
I don't have.
Yeah, you may need to grab another sheet of paper to like staple to these and put in your notes and whatnot. Okay, because they are a linear pair, what can we say about them?
They add to 180, I don't know.
Very good. Yeah, we could say that. So now, though, when we get into addition and equality, we can't just say angle plus angle. What do we have to say instead?
Measure of angle.
Very good. The measure of angle BEA plus the measure of angle AED is equal to what? 180. Good. So you see how we're making a statement, giving a reason, and then using that statement to help us say the next thing. Now, why can I say that?
Is that definition of a line?
It's actually also definition of linear pair. Okay, very nice. So now we have those first ones over on the left-hand side and the bottom. How about the right-hand side? What do we need to say? What else do we need to say?
say CED in words are difficult. DEA is linear.
And I'm going to stay with AED since that's what we've used already.
Well, you don't like the DEA?
We could, but just because I've used AED right here, I want to stay consistent. Why can I say that?
Death of linear. There's gonna be 4 in a row that are just death
Yeah.
of linear pair.
Very good, because what's step number 5?
Measure of angle CED plus the measure of angle AED equals 180. Words are terrible. Curses from me.
You're doing great. And it's because of the same reason. Very nice. Okay, once you get finished writing it, that is where we're going to leave it today. So we have 2 linear pairs, and then we're going to see what we can do with those next class on Tuesday, okay?
Goodbye now. You mean Monday?
Oh, yeah, snap on Monday. Wait, yeah, Monday.
Yes.
Bye-bye. We're back. Okay, here we go. So we have so far that we've got some linear pairs. They are equal to 180 degrees. Now, here's my idea. If we have both of these things equal to 180 degrees, we can also say that they are equal to each other, right? So I'm going to take 3 and 4, and I'm going to utilize those steps to say, okay, in step 6, since they both equal 180, I'm going to set them equal to each other. So the measure of angle BEA plus the measure of angle AED is equal to the measure of angle CED plus the measure of angle AED.
Wait,
What?
measure,
Moving again.
what, I can't see.
Measure of angle BE. Oh, it's supposed to be BEA. Apologies. AED. So I'm taking the left hand of step 3 and the left hand of step 5, and I'm setting them equal to each other since they're both equal to 180. Under what reasoning can I do that?
They're both equal to 180.
True. What is that called? What's the formal name for that?
So the rule of congruency. I don't know.
Close.
EPs, yeah.
No.
No,
That's for triangles.
ABC is corresponding parts of congruent triangles are.
Ooh, he got that whole thing
I
down.
also have the formula for photosynthesis.
Why?
Excellent. Okay, that is not this case though. The simple version that we could say is substitution. Okay, however, that is not what we are going to say because I want you to get the actual true formal version of this down. It is the transitive property of equality. So if 2 things are equal, that can transition to a third thing. Okay, so it is the transitive property of equality.
Would you accept TPE on a quest?
No,
Please.
that is too shorthand.
TPO.
Nope, I want... What I would accept on a quiz is substitution. What I would not accept is TPE. Okay? I would accept trans, prop, of, and then an equal sign. I would accept that. But I want you to give a little bit more.
Transpop O.
What if you're like writing
Trans
a
prop-
paragraph
so-
about the transitive property of equality and you say it and then could you then abbreviate it later?
If you put it in a parenthetical and say TPOE or something like that.
Like in your first sentence and then start using it?
Yes.
I get it. Yeah.
You could say this right here. Trans prop equal.
Okay, so.
Because it still gets the heart of everything, it's just summarized a little bit better.
Shorthand.
Okay. Now, what do I have on both sides of that equal side right now? That's the same.
The measures
You
of an
have
angle.
Which angle?
AED.
I have the measure of angle AED on the left, and I have the measure of angle AED on the right. Ooh.
said the same thing
combine like.
I know. No, I meant to. Because if I subtract the measure of angle AED from both sides, what is the measure of angle AED? On the left side, what is the measure of angle AED minus the measure of angle AED? Nothing, right? On the right side, what is the measure of angle AED minus the measure of angle AED? Nothing. So what will I have left?
BEA and
So
Ah.
measure of BEA plus measure of angle.
So if I subtract the measure of angle AED, so this is not going to go in the formal proof, but if I were to go like this, minus the measure of angle AED and minus the measure of angle AED, which I can subtract something from both sides and the equality is still preserved, right? This cancels and that cancels, right? So all I'm left with is BEA and CED, which check out what angles those are.
Whoa.
It's saying this measure is equal to this measure.
Whoa.
Okay? Which is what I'm getting after, right? Yeah, so that's the holistic
Which is
picture here.
C.
So now we can say that the angles are.
Not yet, but we will be able to very soon. So number 7 is I'm going to write the result of if I were to subtract that, to have subtracted that from both sides. So the measure of angle BEA is equal to the measure of angle CED. So I write the result. Now, why can I say that? I kind of hinted toward it.
Combine like terms or transitive property of equality?
It's neither. It is a property of equality. Say that again.
Subtraction.
Subtraction.
The subtractive property? Oh, is it?
Subtraction property of equality.
relative?
So that means if I subtract the same thing from both sides, right? If I have a balance like this, right? One of those like traditional balances. Woo! And I've got 7 marbles on each side. If I take 2 marbles away from one side, it's not going to be balanced anymore, right? But if I take 2 marbles away from both sides, if I subtract 2 from both sides, it's still equal, isn't it? So that's what we're doing, just in mathematical algebraic terms rather than in ancient
Egyptian.
scale terms. Yeah, you know. So the reason for this is the subtraction property of equality.
Can I write subtractive property of equality?
I put sub prop
What?
equal.
Would that also mean that there is an additive property of equality?
Ah, yes.
Multiplicative and
Yes. Yes.
Division is unnecessary, multiply by fraction.
Facts.
Yeah.
But yes, those are all true, right? Across an equal sign, across an equation, those are all properties of equality. Equality is not changed when we do any of those operations. Yeah, as long as we do it consistently to both sides. That's like the foundation of algebra right there. I love it. Okay. Now, what is the problem asking us to actually, on your page, what's it actually asking us to prove?
The angle equals angle.
Does it say angle equals angle? What does it say?
Angle AEB is congruent to angle CED.
Congruence, right? So angle BEA, AEB, it's the same angle, is congruent to angle CED. Why can I say that?
CPCTC?
That only happens with triangles.
No.
You can say it because two angles that have the same measure are the same.
Definition of linear pair.
Definition of
Measure.
congruence.
Congruency.
Not congruency. Congruency is not a word. Congruence means what do you think that means? Yeah, very good. So it's the definition of congruence. If 2 things have an equal measure, then those 2 things are congruent. Okay, if 2 angles have an equal measure, they are congruent. Very good. Look at us go.
For number 7, I put sub prop of equal. Is that okay?
Yes, ... Gotta put those.
Sub was subway.
Oh my gosh, the subway property of equality.
Yo, I would.
It's 2023, y'all. We're living in the
I
future.
would eat there.
Okay.
Your pasta is just arranged into a grid.
Pasta? Why are you getting pasta at Subway? What?
That's
Like,
the pasta at Subway?
No. I don't know where Tayson,
Yeah,
Tayson's
what
taking his own pasta.
Tason's going to waste some.
Dude, low key, I had a pasta sandwich.
Why not Subway?
And when over Christmas break, it was like spaghetti with meat sauce, and then we had leftover ham from Christmas dinner, and I put it all on a bagel,
Oh, you
and
are
it was.
so
On a bagel?
disgusting. You are.
You think that? You think that? It
No,
was
because
gas.
things like
It
that are
was
not
so
good.
good.
Burn.
Oh my
Like,
gosh,
dad
it was
joking
fantastic.
around with me, it was like,
All right, we're moving on. I don't want to hear your naysaying. We're moving on. We're moving on.
Mr. Rock.
And the next thing that we are doing here is we are going to prove the exterior angles of a triangle. We talked through this last class. So now we're going to take the time to actually prove this, okay? What was the idea? Nope, Jacob. What were the ideas we came up with this one?
Okay, so I'm gonna say this in as much math termy as I can say.
Termites? Okay.
4 and 3 make a linear pair, right?
Yeah.
And since 3 and 2 and 1 also have to add up to 180, you can say,
Why?
because triangle.
Yes.
Okay, so you can say that 1 plus 2 plus 3 equals 180. And
Uh-huh.
3 plus 4 equals 180. You
Yeah.
can do the same. Math terms is difficult. You get it.
The same subtraction property of equality? Is that what you're talking about right now?
Words.
Yeah, buddy. That is exactly right.
There's the
Very good. And then we will have that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So, let's do it, y'all. Let's go. Yeah, dude.
You accidentally send that to Mr. Harris.
No context.
He would get it.
Just trying.
He would get it. All right. So, let's formalize this business. What were we given? Because that's the important thing, right? We always must start with the given.
4
Ah.
is an exterior angle of triangle.
angle.
Angle 4.
Statements, reasons. So, number 1, angle 4 is an exterior angle of triangle of the triangle. It's not named. Also, a little pro tip right now. If you are given angles like this, you can also name them. Like
Howard.
1, 2, and 3 are actually some, because we want to shorten them, not make them longer, right? So we're going to nickname them as 1, 2, and 3. You could name number 1 Howard if you want to, but we'll refer to him as his nickname Howard. I mean, number 1. And that will shorten the process, right? Because then instead of having to write the angle, we can write just angle 1, like we're about to do in this next proof.
Angle Howard.
Angle Howard. Okay, what is the reason for our first statement?
Given.
Mm-hmm. Very nice.
Take a look at that book I sent you that's about like math without any assumptions whatsoever.
I did look at it briefly. I'm excited to spend some more time in it when I get a chance to, because it looked fascinating.
It is very big.
Sweet. Okay, so what's the next statement that we could say? I want somebody else to say this, because Tayson summarized that process of what we're going to do really, really nicely. So I want somebody else to kind of help the process, because pay attention to what we're doing and how we approach these, because I'm going to be asking you to do proofs on your own, right?
It's terrifying.
It's a little frightening. I know that they're daunting. Proofs are difficult, but if you approach it the same way, they're all just logic puzzles. They're how do we go from what we know to the next step, okay? So just kind of pay attention to these processes. So we have a triangle and we have an exterior angle and we can see this, right? So what is another step? What is another thing we can say about what we see here?
All I remember is Jason saying they add up to 180.
Which ones add up to 180?
3
1,
and
2, and
4,
three.
which are
Okay.
exterior. or?
Yes, yeah. Both right. Let's do one at a time. Let's do one at a time. Which one do you want to do first? 3 and 4 or 1, 2, and 3?
1, 2, and 3.
Okay. They add up to 180. Why do they add up to 180?
Because it's a triangle.
Because it's a triangle.
And all triangles add up to one.
Yes. And it is already said, it is already said that we have a triangle in the given, right? It says the triangle. So we can assume that those three angles are inside of the triangle, right? When we're given the graph. So we can then say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to what?
180.
Very good. Now, why can I say that?
Because.
Definition of a triangle, ain't it?
Because it's a triangle, so it's the definition of a triangle. And here's where some shorthand gets to come into play. Def of triangle shape. Triangle shape. Triangle shape.
I'm just calmly.
And now we can
I
say
gotta find out
that
points in
angle, the measure of angle 3
Why?
plus the angle of measure 4 equals 180.
Here's what I'm going to show you. Shh. Did you guys hear that?
What?
Sam just said, now we can say that the measure of angle 3 plus the measure of angle 4 equals 180.
Because
That is step,
definition of exterior.
Isn't it?
that is step number 4.
So me and
Okay,
Sam.
so-
Oh.
What we need to do
Well,
first
you
is
need
we need
to
to show that
sim-
the exterior angle is a
Yeah.
So
What?
you are using this principle, but we haven't said it yet. Angle 3 and angle 4 make a linear pair. That's why we know that they add up to 180. So that's why this is step number 4, because before we can say that, we have to say angle 3 and angle 4 are a linear pair. Why?
Definition of linear pair.
Mm-hmm. Yup.
So I tried drawing my proof thing sideways to maximize space, but it's so narrow now that I
It's
think
not.
This is why you do it
think
on a
it's
separate
worse
piece.
than if I had just written it normally.
Ruh-roh.
Each one takes like 3 lines.
What's a linear pair again?
So that's two angles that are on a line that create that line, right? Oh, that's like a dance move.
You write so tiny.
I'm
That
having
is
to.
giving me flashbacks.
No, you're
So
not.
number 4, Samantha has very kindly told us what number 4 is. What is the reason for number 4?
Is it
Definitely linear pair.
dimensional? Yeah.
Is it
Mm-hmm.
Is the quotation marks an actual mathematical thing, or are you just being lazy?
Quotation marks are just a thing. Like if you put in quotes, it's kind of accepted shorthand that says whatever is
writing it down.
previous.
I put an arrow up. to-
Why?
So I know what the quotations mean then. Like if
Oh.
I look back, I'm gonna be like, what is that?
What?
Okay.
You're not
Like
looking-
why is
Joking,
it
just-
blank?
Definition of a linear pair.
Definitional linear pair. No. It actually means just like you're quoting the previous step. Yeah. Yeah. It's shorthand. Man, I forgot that you guys are learning things still. This is great. It's awesome. I can't remember when I learned this. I just I feel like I just came out with it
You just
in my brain.
Oh.
Learning.
Like, you know.
Burned with math books.
I had to work really hard to understand math. Math is hard, you guys.
Really
Math is hard. Also, Hadassah, will you please staple your papers together real quick for me?
Sure.
I want you to start doing that every time you turn it in, okay?
Sure.
Like,
Thank you.
At the staple
It's right there.
You just patted it like, here, please.
Here it is for you. Number 5. Thank you. Wonderful. The pat. Thank you. Okay, number 5. What you think?
Can we say the measure of? Well, I guess it's the
Okay,
same
the
thing.
measure
measure
of
of-
angle 1 plus 2.
Hold on, Tayson.
Oh wait,
Someone else say
I
it.
have
What do you think, Hadassah?
Would it be, so the measure of the
angles 1, 2, and 3 is equal to the measures of 3 and 4?
Yes, they both are all sets equal 180. Because of that, I can now say that they equal each other, right? Do you guys remember what that property is?
Transverse property of equality.
Okay.
Wrote it.
Wait.
Okay, so now say it then.
Transversive property of equality.
Nope. This is why it's not okay to just say trans either. Transitive, yes. Excellent. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. Wow. And that is the transitive. We're going to write it all out again because you guys couldn't remember it. Property.
Property.
Nope. Transitive property of. You guys remember what equal is, though, so we'll just put an equal sign.
Y'all were-
An equal sign.
Okay, how'd they come up with the congruent sign? Did they literally just say an approximation squiggle and be like, yep, that's it? Or-
They just gave an equality a comb over.
They were just done with.
Doesn't it kind of look like if you gave something a comb
Oh,
over?
yeah, like he did his hair one day.
It's like,
So the normal equal sign has like leukemia or something, and then that one is.
What?
It doesn't have any hair, so.
no, there you go. Look, that's it, right there.
Number 6.
Okay, that's how you knew. Number 6. Shh. What can you say about number 6?
Measure of angle 1. Oh, do you want somebody else to do it?
Yes.
Oh.
Okay.
Wait.
Now
Wait.
do we-
Wait.
Now
I want wait. I want somebody else to do it. Someone that has not spoken
I'm
yet.
guessing though.
Good job, Jacob.
Shh. There are 2 people without their hands up. You are the 2 that have not spoken yet, so you need to say something. We have already done this exact same process in the previous proof. Shh. So how do we go? Look at your papers real quick, you 2. Hey, I'm leaving it for just these 2. Don't whisper anything.
One.
Look at your paper. What are we trying to prove? In the question. Shh. What are we trying to prove?
Measure angle 4 equals measure angle 1 plus measure angle 2.
Very good. Now, William, she took that one. This one's for you. How do we get from here to what she just said?
From there to what?
From here to what she just said, yeah.
I'm just gonna raise my
How
hand.
far am I looking at?
Yeah, shh, shh, shh. Hold on. What do they have on this? What do they have on each side that's the same?
That's the same. I can't read your handwriting or mine, so I'm.
Okay, you got to be able to read one of them.
You write so small.
You can get closer. Shh.
Okay, they each have angle plus and equaling to each other.
Which
I
one?
I think that's what it says. I can't read it. 1 and 3 and 3. I think.
They have 3 and 3 on each side. Very
It's like a
good.
2.
Which
So if they have 3 and 3 on each side, what can we do? One of you 2. What can we do? We can subtract it, right? Very good. Is that what you were going to say?
Subtraction property of this.
And that is the reason. So we can subtract the measure of angle 3 from both sides. Very good. Measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4 because we subtracted the measure of angle 3 from either side, which is the subtraction property of equality. Also, William, just as a reminder, you can move anywhere in the classroom. So if you cannot see, come closer.
Do you think I'm
It is
And yet, Mr. Ball, it's also me. I can talk to anyone, so.
Well, that's fine. You can move closer and see. That's okay.
And then proceed to talk, and then you tell me to go back.
Well, what do you want to do?
Exactly how this is gonna work out.
What do you want to do?
Write this stuff down and write down the 2 that looks like a 3.
Okay, sounds great. You can move closer. Just have discipline to not talk.
It looks like a 2, not a 2 that looks like a 3.
Anyway, here we go. So, is that what we were trying to prove? Tayson? Is that what we were trying to prove?
Yeah, draw the 3 little dots.
Yes, draw the dots. Dot, dot, dot.
wait, what does that mean again?
means
We're done.
we are final. The proof is finished. Finis.
Say,
It is finished.
It's an easier way to say the end.
so you don't have to say.
I'm gonna end my essay with 3 little dots.
Miss Gomez.
Miss Gomez is gonna be like,
Do you end your essays with the end?
Um,
no, you
Sometimes
should.
supposed to.
It's Tayson, of course. You
You're
started
supposed
all
to.
of his speeches with.
I know I could have.
Okay.
I see that now.
I did.
Okay. So,
Little
Okay.
bit.
Can you even read
She
it?
had to tell me to stop saying the word okay or or any sort of thing.
Okay.
Yeah,
This,
he would get up
okay.
there
Dude,
and be.
that is,
Okay.
it is a filler word. And you do also say that in response to when I say good morning to you. I'm like, good morning, Tayson. And you're like, okay. I'm like, wait,
No,
what?
what's even worse is it was always okay. So and then
Okay, so.
Reach. Don't start with okay. Okay.
oh, okay.
All right, parallel lines cut by T-transversal.
T-transversal.
So here's what I'm going to tell you because this first one is kind of sus. All right. What they do for this first proof, and so I'm telling you right now, we are not going to do this proof because it's a little wonk. Yep. So what they do is they say they're trying to prove that corresponding angles 1 and 5 are congruent. What does corresponding mean again? They're the same side and they're on the same side of the parallel lines too. So like you can basically slide it up this transversal and it would fit.
I was gonna say one's interior, one's exterior.
Oh yeah, that's a good way to say it. So same side, one's interior, one's exterior. Yeah, that's a great way to say that. This is basically what they have said for their proof. They're like, so if you were to take line CD and slide it along the transversal until you got to point B, where A was at point B, then angle 5 would be overlapping with angle 1, and they're the same.
Yeah, no.
Whoa, really?
So that's the proof that they use. So we're just going to be like,
Nah.
okay.
Okay.
And maybe even say like, slide to the on the transversal.
The thread.
So slide along transversal is what we're gonna say.
Sorry, then we're not doing 4 then?
Oh, we are doing 4. Because now we can use the fact that corresponding angles are congruent. So, number 4 is asking us to get what?
Alternate interiors 3 and 6 are congruent.
Very good. They're asking us to prove that alternate interior angles, angles 3 and 6, are congruent. So what are things that we know about angles that allow us to say congruence? Like what are some, if you were to look up here and just talk through this, what are some angles that are congruent? And I'm going to ask you why we know that they are as well.
3 and 2.
Angle 3 and 2, 2 and 3, right? Why do we know that they are congruent?
They're a linear pair.
They are not a linear pair.
They are.
Vertical angle.
Opposite, which is called vertical angles, okay? So they are vertical angles, which are opposite, right? We know that vertical angles are congruent. In fact, we just proved that.
Wow.
So now we can use that
Yeah.
in another proof. So rather than having to say angle 1 and 3 are a linear pair and angle 1 and 2 are a linear pair, and then if you add them together, it is 180, 180 substitution. Rather than having to redo that entire proof in this proof, we can just be like, angles 2 and 3?
David,
Yep.
David.
They're congruent. You want to know why? Because I proved it. They're vertical angles.
Oh, so we
That's-
just say
that's
3 and 2
Okay.
are vertical, so congruent, and 6 and 2 are vertical because they're corresponding.
Did you miss it, Jacob? I think you missed it because you were saying words instead of listening. 6 and 2 are what now?
The corresponding.
Corresponding angles. So we know that they are congruent as well.
Did you just see this?
Okay. Because they are corresponding because of the slide and K, that is how we'll know. So then we can say that angle 3 is congruent to angle 6.
Whoa.
Let's formalize it. Here we go. Chop chop. Got that. The queen is coming.
Wait a minute.
I would hope not.
Oh, Princess Diaries.
I did quote Princess Diaries. That is correct.
I love that movie.
I did in fact do that
They're
thing.
great movies.
No, they're not. I had to watch them for my sister's birthday. They're terrible.
Okay, here we go. So step number 1.
Fortune. It was so bad. It was.
Ooh. Say it again, Sammy, louder for the people in the back. What'd you say? Yeah, we always start with the given word.
You don't have to write so tiny, big box.
Time to draw sideways.
The given here, Bill, I will try to help you solve one of your problems by writing larger. You're welcome. Since you didn't want to take any action,
Many
here we go.
problems,
What?
One of them being that
No,
you
ju-
write too small.
Okay, what is the given? Jacob.
Mine. Oh, you want Jacob?
He raised his hand. It was very polite. I appreciated that. No, W. Tayson, you should try it.
Because well, you helped because I forgot what the arrows on the top of it. So
Line.
line, the is
Yeah, he was asking
I
a
forgot
question.
parallel.
Yes.
Parallel to line 80.
Line what and what? Sorry?
Oh my goodness.
You said EF?
BF. BF.
Oh, it's an easy fix. BF is parallel to
Line A, Z.
I
AZ?
do that all the time. Whenever
Oh,
I try to
G.
write
G.
Mr. Ball, whenever I try to write like an E or an M, I'll write the opposite.
So weird.
And so I have to just like try to transfer it over. Like when I'm trying to write an M, I'll draw like an E for
Okay, number 2.
I see another slide.
What did we...
That number 1 by the given looks like a head.
It's like...
Face.
That's what it looks like.
I see it.
Okay, what's the next thing we talked through?
That 2 and 3 are congruent.
Okay, why... So I'm going to tell you right now. That is step number 3.
Or a linear pair. Not a linear pair, they're vertical angles. Linear pair is
I
different than
said it.
vertical
They're
angles.
and
Shh. So angle 2 is congruent to angle 3 is step number 3, but we have to do something before we say that.
like the transversal
Eh,
line.
And Austin said it. And then
We can assume that that's a part of the given. That AB is a part of the given. Okay? Hadassah, yes.
Angles 3 and angles 2 are vertical angles. 'Cause they're
Wunderbar.
What?
Oh, wait. What?
Wunderbar?
Oh.
Wunderbar.
What is that supposed
Wonderful.
to mean?
It's German for wonderful.
Wunderbar.
Wunderbar. Wunderbar. Why can we say that they are vertical angles?
2 and... Cause...
Definition of what? Yep.
Vertical.
Nope, vertical. I'm also just going to write vert angles.
Defavert. Wait, can we nickname Vert to be like Victor or something?
Oh, yeah.
Now, why can I say that these two angles are congruent now?
Definition of vertical angle.
Ah.
Just draw a quotation mark.
Boom. Okay, so that gets us from 3 to 2. Now we need to get from 2 to 6. How did we do that again?
By using the above proof we didn't do.
We could say that
They're congruent.
angle 2
They're
and
congruent.
angle 6 are corresponding angles.
Yes, and that is the correct order. We're doing that next. Yes. Angle 2 and angle 6 are corresponding angles. Wow, that looks like a G. Corresponding. No, corresponding angles.
Mr. Freeman today was talking like
Is that definition of corresponding angle?
Mm-hmm.
Swear.
corresponding.
Gru is
Gorls.
spawning. Gru is spawning.
Gorls.
He's spawning in.
Shh. What can we say because of that?
They are
That angle,
congruent.
yeah.
Angle 2 and angle 6 are congruent.
Mm-hmm. You guys are doing a really good job of getting this order down now. That's fantastic.
Yeah,
That's
William.
kind of swag. Not gonna lie.
He is too. All right. And finally,
Oh my goodness.
oh my goodness. Guys, we're at the last step.
Whoa!
What's the last step?
Angle 3.
And angle.
Wait, are we at the last step?
Dots.
No, we need to write the angle 2 and
Oh,
angle 6.
No,
angle
because it
3
stops.
and angle 6 are alternative, angles. Interior.
That is what we're trying to prove, so we cannot use that yet.
Okay, so
We're
we
not
need to write
saying they're congruent, we're saying that they're alternative.
Alternate, interior.
Alternative.
But we are trying to prove that alternate interior angles are congruent.
At the last
Wait.
step, because we need to write out that angle 2 and angle 3 are congruent, and then that angle 2 and angle 6 are congruent, and then we can use the subtract the word to.
Why do we need to write out that angle 2 and angle 3 are congruent?
Well,
We already
can
said
write them
that.
together.
I think what
Wait.
Tayson's trying to say is you need to do the
Wait.
angles. No, actually no.
Yeah, don't you need to set them equal to
You
each
don't-
other?
Mr. Ball.
So angle 2 is angle 2, right? It's itself. So now I can take this and put it in the place of that.
Yeah, we would do the subtracting.
Yeah.
Not the subtracting thing this time.
Substitution thingy.
Substitution. Or you could also say it's the transitive property of congruence, because congruence has a transitive property just like equality does.
Wait,
Substitution. Does that make sense?
kind of.
It's a little easier to think about like doing it like the subtraction way. Right? Like
But that's so we're doing in the previous one. Let's look back at that for just a second. In the previous one, this is the step number 5, where we said since this is equal to 180 and this is equal to 180, we can set them equal to each other. What we're saying now is since angle 3 is equal or congruent to angle 2 and angle 6 is congruent to angle 2,
Oh,
that means
angle
angle 3 is
and-
congruent to angle 6.
Okay, so we're.
That's what we're saying right there. Yeah. Great. I'm glad we had that talk. This is wonderful.
now the $3.
That
Hello.
you were mixing like Slavic and
Oh, we almost said.
Duh.
Uh,
Dibbity dot dot
and
dot
it's
dot
also
dot
kinda
dot.
Scandinavian as well. And then
Scandalous. No, Scandinavia.
Just say Wagon.
Judith. Okay.
Judas, no.
What? No, what?
There we go. So now, now y'all, we have proven vertical angles. We have proven exterior angles of a triangle. We have proven sort of corresponding angles. We said, okay, you slide along, get slidey slide. We have proven alternate interior angles. That means we can now use all of those things in proofs. Okay, just like we just used vertical angles in this proof. We used corresponding angles in this proof. Now we can use these to our benefit and for our good.
I'm gonna do that for the rest of the
Now,
The dude from Brave now.
I can't.
I know it. It always reminds me of Brave.
It's a good man.
That's
The
Morelli's
most
favorite
cursed
movie for some
fraud.
reason.
What are we trying to prove now?
That same side interior angles 3 and 5 are supplementary.
Very good. Shh. Thank you, William. The rest of y'all, focus. Please. You need to focus. Thank you. Okay. Same side interior angles, angles 3 and 5 are supplementary.
Oh, I get it.
So hold on, everybody think about it for a minute. Okay, because I want you to get through this process. How do I do this on my own? Because you will need to do this on your own.
Just tell me what
Okay.
I can say.
I will tell you. Tayson, you have it?
Yep.
Okay. Here, go ahead and will you run me a quick errand?
Well,
I will.
or
No, you're thinking about this because you don't have it yet, do you? Do you have it? What? You don't have it? Not yet? Okay, keep thinking about it.
You want water or you want
Bon café, por favor.
water?
It's
Works
half
for
that.
me.
Oh wait. I heard coffee. Then it was like,
Bon café, por favor. Actually, that was
coffee, please.
Creole because bon is French. Hey, Hadassah. Think through it. This is a good one to practice. Think.
So is the like, are we proving that?
Oh, I like it. Looking back at some previous. So that you can figure out what to do here. Get some ideas going. Some ideas flowing. Ooh, we also know. I forgot to say this, but we also know linear pairs.
Okay, I would assume you didn't want the whole thing filled, so.
Why?
Because you want to sleep tonight, don't you?
It's 10 in the morning.
Jason, I felt like
My
8
caffeine
o'clock.
cutoff is 4 p.m., but I do appreciate your consideration. That is very
Mine is
thoughtful of you,
6.
Tayson.
Guys, imagine
I've
drinking
had caffeine past like 6.
I know, I wish I
Like, have
didn't.
an energy
I envy
drink at,
you.
like, 5.
All you purists that live off of water instead of coffee.
For
You're
real,
actually
for
missing
real.
out. And Powerade. Water and
Oh,
Powerade.
but Powerade is goated. Powerade's so good.
Hey,
Small.
you know those little shot things of energy?
Thank you, Tayson.
Okay.
What about
Power
them?
So
energy.
my work has them because we do a lot of physical stuff, and I don't know why. So I drank one because I was like, why not? And everybody was staring at me because apparently you're not supposed to drink the whole thing. You're supposed to do it like a quarter at a time. And I just drank the whole thing in
You
one
just
sitting.
downed it like a
And so
shot.
everybody, basically.
All I can imagine is Tayson is like standing at the table, 5-hour energy in hand. Everyone's like surrounding him. And they
All right, we are going to do this. Who has some ideas about what to do? Jacob, I saw the hand. What you think? No, okay, no, none of that. That conversation is over. Hadassah, what do you think?
Angles 3 and angles 2 are vertical angles, which would be a definition of vertical angles.
Okay, how will that help us? Okay, that's not incorrect. That's not incorrect. I like that you're thinking about things we know, right? But then I also want us to think how does that help us? Tayson, you are making so much noise.
He's kicked me 3 times.
Oh my gosh.
Dr. Young's gonna call you.
Okay, what else do we know here? What else do we know?
Well, first, you gotta say.
Okay.
I like that you picked one of the angles that they're asking us to think about too. That's good.
Could you also do 5 and that
So
one out?
can I answer now?
Hold on, Jacob.
Because like there's 1 and 6 that are kind. My brain's not really.
Yeah, but the only thing is that's not in our final.
Can I answer or?
Yeah, that
That's
doesn't
not gonna help.
not
That's
yet.
gonna include 5
We also
and
don't
something.
know anything about 1 and 6 yet, right?
Okay.
One's on the outside, one's on the inside. They're on alternating sides. If they're same side, one's inside, one's outside, that helps.
5 and 7 are something that I can't
I'm
remember what the
even
word
raising
for
my
it
hand
is.
this time.
Oh, Tayson, I like that your hand is raised. Yes, sir. I like 5 and 7 are something. Let's think about that too. But yes, Tayson, what you think?
Okay, so we need to prove that 3 and 5 are congruent. Okay.
No, we need to prove that they are
They're
supplementary.
Words are different.
It's okay, but I'm glad we cleared that up. I know that that's where your head was at.
Okay, so we know that since 3 and 5 are alternate interior angles, no, 3 and 6,
Okay.
right? And that's 5, so 3 and 6 are alternate interior, and we proved right on the other page that that means they're congruent. We can essentially switch out 3, 4, 6, and then we can see that 5 and 3 are a like linear pair, and therefore they're supplementary.
Yes. Very good. I do want also to proceed from Hadassah's line of thinking.
Yeah, 3 and
She's
7 corresponding.
3 and 7 are corresponding. Yes,
That's the word. I was
they're
thinking
corresponding.
supplemental. No, that's not right.
And then so we could do either one. We could go to 3 and 7 and then say that these two are a linear pair, or we could go to 3 and 6 and say that these two are a linear pair. It's actually the same line of thought. We're just going to either use alternate interior angles or we're going to use corresponding, but we can use
Which
both.
We proved in the earlier.
We got it, yo. So let's do that. Okay, which one you want to do? Which one you want?
3 and 7.
3 and 7. I like it. Let's go with Hadassah. Woohoo! You're doing great things. This is marvelous.
Our genius.
You?
Definitely.
It is.
Sure.
It's 3 and 7. We're using yours, dude. Come on. Come here. Oh.
It's the same as.
I know, but I want a new oh. I want a new a new note. Thank you. Okay. So, what did we first have to say? No matter what.
You should
Mhm.
build an entire folder in
And it's
the
the same
notes
as last time.
dedicated to proofs and save them all there.
That would be great, except for the fact that I do these proofs with my students every year, so saving them doesn't help me.
Then why
I
do
got
you
them saved,
follow-
Tayson. You want to know where they're at?
My brain.
You're
Right up here.
That is the most teacher thing ever. I have all of this material saved in my brain because I've been doing it the same way for the
I
past
hit Command
7
S
years.
on this business. All right, here we go. So what's the given?
It's
BF
line
and AD
BF
are
is parallel to line AD.
parental figures.
Line BF is parallel to line AD.
Keep it.
Again.
Winky?
Oh,
Yeah.
Sam. Oh,
Number
Sam.
1. I'm a
Okay.
given.
Sure.
Wait, that's okay.
What is that now?
Mine's
That is
better.
your
It's
angry
not.
bird.
That
Or
is more than
mine's
an
doing
angry
twins.
bird.
No, it's an angry bird, like them little, you know, the yellow guy.
I gave it a mouth and a squint and
Fat
eyebrows.
boy. Boy.
Yeah.
Let's
Bird has
go.
a cursed drawing on their finger.
Okay, number 2.
Mr. Bob, look.
Mom, look.
I love it.
It actually is kind of cute.
I-
Okay, number 2. What is our next step that we want to do? We said 3 and 7, yeah? So what do we say about 3 and 7?
They are corresponding angles.
Angle 3 and angle 7. I love this teamwork. Are corresponding angles. And how do we know?
Definition of corresponding angles.
Very good. Now, what can I say because of that?
Then is congruent.
You're welcome. Oh, I can say that angle 3 shares congruence with angle 7.
Bro, I was rewatching Moana like a couple days ago, and it was like fire. Like,
It's
I
a
think
great, it's a great TV
I
show.
can never remember Big Crab Dude's name. The shiny shit.
Tom Poe.
Shiny! That one?
Jason, my
I hate that
My
I know that
spider
off the
crab
top of my
companion
head.
and
It's
crab
purely
Is
because
that,
my
it's the
brother
same
used
guy,
to
right? The
love-
Shiny!
Yeah.
Yeah.
That guy is,
My grandma.
he's from he's from a band called Flight of the Conchords, and they have some of the most hilarious, I don't know that it's appropriate, so don't go look it up. But they have some of the most hilarious, like just language stuff. They've got some of the most
Oh,
hilarious.
language stuff?
Oh, no.
Sorry.
I watched Ted Lasso.
What?
Okay, I won't recommend it because I don't recommend language, but
Mr. Wolf.
You know,
Video you
I-
watch. Just curse at the end.
oh gosh.
It's- I'm
Really sorry
we're
about
done.
And way to ruin a good thing there. Okay, number 4 now. So now we have angle 3 and angle 7 are congruent. So we could substitute angle 3 for angle 7 at any point. But before we do that, oh, this is, can't draw on that. Before we do that, what should I say? How do I go from angle 7 to angle 5? How do I relate those two? What are they?
With a vertical pair. Or is that not? Wait, hold on. Angle 7 and angle.
Running it equal like 180.
Yeah, vertical No, linear pair, not vertical.
Linear pair.
Words are difficult.
So angle 5 and angle 7, very good, are a linear pair. And then you were saying that they equal 180, right, Sam? Because they are supplementary, yeah? So linear pairs are supplementary. So let's go ahead and say that that is first the definition of linear pair. Because we want to know that they're supplementary, right? So now what we should say is we want to know that 3 and 5 are supplementary. But before we can do that, we have to say 5 and 7 exactly. Mm-hmm. You guys are crushing this game. And why can we say that?
Definition of supplementary.
Linear pair.
Yeah.
Same dang thing as right before.
You sound like the dude from Forrest Gump now.
Forrest Gump.
Yeah,
I was just gonna say, it
Oh.
sounded like Ted Lasso, but
No.
I've never watched Ted Lasso. I cannot remember
it's.
having ever seen Forrest Gump, actually.
Forrest Gump is fine.
I've only seen
Dude,
like
Bubblegum
the
Shrimp, you know the place in Chicago is so good.
Dude, you're on a different level.
I know.
So,
This is-
then,
That's the whole joke.
5 and 3 are corresponding.
angle 3 and angle 5, what are they?
Supplementary. They're
Are supplementary.
Your thing's ringing.
Why can I say that they're supplementary? How did I relate 3 to 5?
Definition of linear pair?
Nope.
No, not definition of linear pair, definition
Vertical
of
levels.
congruent
Hi.
substitution.
Definition of corresponding.
Do I? Yes,
No,
I
it would
put
be
myself down in
one
there.
Thingy. It's the transverse,
Oh, shoot.
transitive property of congruence.
Gotcha. Yes, I do, and I got doubles as well. Thank you. Goodbye.
Wait, doubles of sloppy Joe?
Yeah.
Mr. Freeman never tells us what's for lunch.
Mr. Ball's a
Why not?
So
transitive
it's always a
property.
surprise.
Oh, that's kind of exciting. Okay, why can I say this though?
Transitive property of
Properties
congruence.
Very good.
Well, see, Jacob, it would make sense for him to do that if lunches were free, but now that they cost money, it's kind of that's
Oh, so now that they cost money, y'all are considering if you really want it or not.
Why do you think?
Free stuff.
Isn't that just an interesting commentary about life in general? When it's free, you just take as much as you want,
Yeah,
right?
there's
As much
no
as you want, more than you want even.
I wonder, can you get.
Well, Mr. Ball, when we're paying money to get bio waste,
That's a
I
good
mean,
question.
I wouldn't classify it as bio
like,
waste,
the bean burrito
but
in it is bio waste.
maybe what you do with it is bio waste. But get it?
Yeah, we
You get
it.
it? Okay.
Hey,
Um,
guys, one more.
However,
I wish to know the answer to Sam's question.
like I just think that it's really interesting that we're just like willy-nilly ordering food when it's free. BT dubs, there's no such thing as a free lunch. Guess who
Yeah.
paid for it? Everyone who pays taxes. Free.
Let's go, not me.
Free.
I pay taxes. Yeah.
You do pay taxes, Tayson.
Okay, I pay income tax.
Guys, we have
Exactly. So anyway, no such thing as a free lunch.
I was like,
And you guys are much more considerate about being wasteful when you're paying for it, aren't you?
Not really, no.
Well, no. Okay, no.
These
You should be.
lunches are trash.
That's facts. Public school.
No, it's
Mr. Ball, I have no.
Simmer
actually,
down.
People.
Okay, we are off task.
like, okay, okay,
People.
more.
people of the internet.
Okay, alternate interior angles 3 and 6. I actually like them. So there you
No,
go.
I like some of
but they
them.
barely
Great.
give you anything. We're
Okay,
high schoolers, not
simmer
elementary
down.
kids.
You guys should really actually talk to ASB. You should like.
It's not
Yeah.
ASB's job. It's
We
the federal
should be
school
separate
program.
from.
Okay.
We tried
middle
doing it
school
last year and it got
elementary
shot
school.
down instantly. Like,
It did.
yeah.
Write a letter to your state representative.
Okay.
Because I also have no control over that. Like, I wish I did. I think that it's
we,
whack.
We tried.
Hey, she
But-
should help us. We're being
We
held
should get
captive on an
2 of
island off the
everything
coast of
for the
Hawaii.
same price.
More to the flies?
All of this is going out of the YouTube video. I just want y'all to know that right now.
Yes.
Okay, we can either do this one together, or if you guys would like to continue talking like you are, you can do it by yourselves.
Oh, I didn't put the 3 dots. Sorry. I didn't put the 3 dots.
I didn't either, Jacob. Let's do this together. dot, dot, dot. Woo! And there was much rejoicing. Okay. Oh, we're done.
W was.
ABB done?
Yep.
Wow.
Yep.
Why?
Because this is another one that they are saying.
It slides up.
This one's even better. They say if you were to create a midpoint, find the midpoint, and then rotate the entire thing 180 degrees, you would be able to see that this congruent angle would sit on top of this congruent angle and that these are parallel.
Whoa.
That's stupid.
And then this is how I imagine them finishing this proof. And then just being like, see ya. It's like, what?
Great
All right.
work.
Nice shot.
Yo, Mr. Wilson.